Assalamu'alaikum wabarakatuh. Come back my YouTube channel. Okay. Before I want to introduce myself. My name is Abdullah. My major is chemistry and faculty of science and technology. Islamic University of Radèn Fatah Palembang. Okay. Today I want to explain about the Page diagram and integration of the Clapeyron equation, effect, and freezer on the paper freezer, the first rule of the problem components. The Page diagram examination of peak at a constant freezer indicates by the dashed horizontal line shows the melting point and boiling point of the substance as the intersection of the horizontal line with S-1 and 1 min G source. These intersection points correspond of the intersection of the mu min T, so that we have mu min T, and serve at temperature below Tm. The solid is stable. There's at the points between Tm and Tb, the liquid is stable, so that we have Tm and Tb. This is a liquid stable. While above Tb, the gas is stable. Illustrations such as convey more information than those such as, and figure is called a Page diagram or a equilibrium diagram. The Page diagram shows at a glance the properties of the substance: melting point, boiling points, transition points, triple point. Every point on the Page diagram represents a state of the system since it is described value of T and V. The lines of the Page diagram divide it into region labeled solid, liquid, and gas. At the point that describe the system falls in the solid region, the substance exists as a solid. If the point falls in the liquid region, the substance exists as a liquid. If the point falls on a line such as 1 min G, and the substance exists as a liquid, and vapor is in equilibrium. And 1 min G curve has a device where it limit the interstitial pressure and temperature, so that we have temperature and pressure. Since it is not possible to discuss between the liquid and gas above this freezer and temperature. The Page diagram for carbon dioxide, we have carbon dioxide. The Page diagram for the carbon dioxide is shows systematically in peak. The solid liquid line slopes slightly the right since we have V liquid bigger V solid. Note that liquid carbon dioxide is not stable at pressure below 5 atm, so that we have carbon dioxide 5 atm. For this reason, dry ice is dry under ordinary and atmosphere freezer. When carbon dioxide is confined to a cylinder under freezer at 25 Celsius, the diagram shows that if the pressure reaches 16.7 atm liquid, carbon dioxide will form. Commercial cylinder of carbon dioxide commonly contain liquid and gas is equilibrium. In the pressure in the cylinder is about 16.5 atm and 25 freezer Celsius. The Page diagram, so that we have the Page diagram. The Page diagram for water. Picture is the Page diagram for water under moderator pressure. The solid liquid line leans slightly to the left because, and we have P liquid bigger. This is V liquid um, we have bigger fish solid. So the title is the triple point at 001 Celsius and 611 VA. The normal freezing point of the water is 8, and increase in the freezer describe the melting. So that we have the diagram. And this diagram. This diagram is diagram for CO2. This 25 Celsius. This is 67, and then you have a diagram for water. This is liquid, this is gas, and we have solid. Point of water, this lower melting point under the pressure exerted by the weight of the skater throws the knife edge of the skate blade is part of the reason that ice skating is possible. This effect, together with the heat developed by friction, combine to produce in the lab resting layer of liquid water between the ice and the blade. In this connection, its intensity is too low. The skating is not good. If water is studied under very high pressure, severe scattering modification of ice are observed. The equilibrium diagram is shown in ice is ordinary ice S1, S2, 3, 5, 6, and 7 are modifications that are stable at higher pressure. The range of pressure is so large that we have S min G, and we have 1 min G. Curve lie only slightly above the horizontal axis. The Arnold source is the figure is remarkable that under very high pressure, melting ice is quite hot as ice 7 melts about 100 Celsius under a pressure 25,000 atm. So that we have ice 2, so we have ice 7 and 100 Celsius and 25,000 atm. Okay, the page diagram. The page diagram for sulfur. Figure shows the page diagram for sulfur. The stable form of sulfur at ordinary temperature and under 1 atm pressure is rhombic sulfur, which is has slowly trends. So that we have the diagram. This diagram. Okay, we have we will drawing diagram. This is 1 area. This is 2 area. This is 3 area. This is 4 area. This is 5 area and 6 area. From the solid modified sulfur at 19.54 Celsius above 19.54 Celsius, monoclinic sulfur is stable until 116 Celsius is reached. Monoclinic sulfur melt at 119 Celsius. Liquid sulfur is stable up to the boiling point 355. The transformation of one crystalline modification to another is often very slow, and if rhombic sulfur is heated quickly, its the melting point of rhombic sulfur is shown at fraction of pressure. The equilibrium as rhombic, we have as rhombic this as rhombic to as liquid. Its example: a metastable equilibrium sense the line is the region is stably monoclinic, superstalled by this line. In this region in the direction that we have sulfur RH to sulfur mono, and we have sulfur liquid to sulfur mono. Okay, the integration of the Clapeyron equation. Okay, the integration of the Clapeyron equation. Okay, we have differential v to differential t and delta s per delta v, so that we have integral dv same integral delta h per delta v. We have condensed phase gas equilibrium. We have differential v for differential t same differential s for differential v same delta h per t and v a for v a. So that we have effect of freezer on the paper freezer. And the prediction description of the liquid paper equilibrium, it was impliedly assumed that the two pressures were under same pressure P. Possible to keep the liquid under a pressure P and the paper under the paper pressure P. Then the paper pressure depends on P. Suppose that the liquid is confined in the container source. In the space above the liquid, the paper is confined together with a portion gas that is unstable in the liquid. The paper pressure P plus the pressure under the portion gas in the P, the total pressure exerted of the liquid. As usual, the equilibrium condition, we have mu paper pressure and T V, we have mu liquid and T and P is same. At constant temperature, this equation implies that V same Fv. To discover this functionally, the parents saw with a respect to keeping of the constant. We had the phase rule. The constant of the phase, the equilibrium implies the condition. We have mu Tv. We have same to mu v. This mu t, we have some mu t, t and t is same, which means that the two internship variable conditionally needed to describe the states of system are not longer independent but are related because of the relation on only internship variable. Either temperature or pressure is needed to describe the states of the system. The system has one degree of freedom or is urinary where only one phase is present. Two variables are needed to describe the states, and the system has 2 degrees of freedom or is Biperian if 3 phases at present. 2 relation exists between T and P. Okay, the problem of component. We have the problem of component. The number of components in a system is defined as the least number of chemically independent species that are required to describe the composition of various phase and in the system at face value. The definition seems simple enough, and in ordinary practice is an example A. Number of examples will show that the joker in the is a dog. The little phase chemically independent. The system contains we have VGL, VGL5 and VGL3 and Cl2. There are three species present but only two components because the equilibrium. We have VGL5 with same to VGL3 plus Cl2. Established in the system, one can alter the number of moles of any two of the chemical independent ability, or alternation in the number of moles of the third species in then fixed by equilibrium condition, so that we have Kx or K total and X PGL3 and XGL2 per XGL5. Okay, thank you so much for your watching. I hope my videos we can benefit for all. Okay, Assalamu'alaikum warahmatullahi wabarakatuh.